Are we alone in the universe? It doesn't seem like LT. Scientists have investigated the possibility of life on other planets for many years. They recently discovered and suggested that liquid water may exist on Mars, raising new questions about the potential for extraterrestrial life. Join us as we examine these findings and their potential implications for the ongoing search for life beyond Earth. From ancient oceans to present-day seeps, the story of water on Mars is intriguing. You see, for those unaware, Mars once had water flowing over the surface, but it disappeared several years ago. However, a new study suggests that in addition to being lost to space, much of the liquid water could have been trapped in minerals in the planet's crust. Where did the water on Mars disappear to? Well, you have to come along to find out. So buckle up for the ride as we unlock the secrets of the red planet and the possibility of a wetter Mars than we ever imagined. Scientists have suggested that Mars is now a desert landscape because it is too tiny to retain moisture. There isn't a specific history of water on Mars. We can even say it doesn't exist. It is the second most minor planet in the solar system and is at the outer edge of the zone where liquid water can flow. Evidence shows that Mars may have once had flowing liquid water, but this study also suggests that it didn't last long. Researchers studied the chemical makeup of Mars meteorites that have fallen to Earth and found that Mars didn't have the necessary chemistry to hold on to water long term. The planet lost most of its volatile elements during formation, which is needed for liquid water and other factors required for life. Unlike Earth, which could retain these elements, Mars could not hold on to them. Scientists have been trying to understand for decades how Mars, now a cold desert, lost its water while the Earth retained its moisture and became a hospitable planet for life. A recent study published in the journal Science by geologists and atmospheric scientists suggests that much of Mars's ancient water could be trapped within minerals in the planet's crust. Unlike previous research that suggested the water escaped to space due to the sun's radiation, meaning Mars had much more surface water in the past than previously thought, and that the early eras of the planet may have been more suitable for microbial life. The study estimates that 30 and 99% of the water were incorporated into minerals in the planet's crust, while the remaining fraction escaped into space. The study suggests that Mars may have been a blue planet for a short time. Scientists have long believed that Mars was once water-rich, based on evidence from remote sensing studies and analyses of Martian meteorites dating back to the 1980s. NASA's Viking orbiter spacecraft and more recent rovers, such as the Curiosity and Perseverance, have returned images of Martian landscapes marked by river valleys and flood channels. However, no liquid water currently remains on the surface of Mars. In 2012, the NASA Curiosity rover found direct evidence of flowing water on Mars in the past. The rover discovered that surface soil on the red planet was about 2% water in its composition by weight. This means that astronauts on the planet could potentially extract 2 pints of water from every cubic foot of Martian dirt they dig up. The study, published in the journal Science, is one of 5 that report on what researchers have learned about Martian surface materials from the work that Curiosity did during its first 100 days on the planet. The rover's primary mission was to determine if Mars could ever have supported microbial life, and it achieved that goal in March when it found that a spot near its landing site called Yellowknife Bay was once habitable. A recent study by researchers at Cambridge University used spacecraft laser altimeter measurements from NASA's Mars Global Surveyor satellite to map the topography of the Martian ice caps, and detected subtle patterns that matched computer model predictions for how a body of water beneath the ice cap would affect its surface. The study suggests that there may be subglacial liquid water beneath the ice caps of Mars, which would have significant implications for the geology of the planet. The team believes that the geothermal heat needed to account for the subglacial water may come from magmatic activity that has occurred relatively recently in the subsurface of Mars. The discovery of subglacial water on Mars is a significant finding, as it can provide new insights into the planet's geology and potential for life. Water is a crucial ingredient for life as we know it, and liquid water beneath the Martian ice caps could provide a potential habitat for microbial life. The study also raised new questions about the history of water on Mars and how it transitioned from a water-rich environment to the cold desert it is today. The team concluded that their study, which was based on the laser altimeter measurements and 2018 computer modeling of the Martian ice caps, had provided new evidence for the existence of subglacial liquid water beneath the ice caps of Mars. This discovery is significant for understanding the geology and potential for life on the red planet. New findings from NASA's Mars Reconnaissance Orbiter, MRO, in 2022 provide the most substantial evidence that liquid water flows intermittently on present-day Mars. Using an imaging spectrometer on MRO, researchers detected signatures of hydrated minerals on slopes where mysterious streaks are seen on the red planet. These darkish streaks, known as recurring slope linei, RSL, appear to ebb and flow over time. They darken and seem to flow down steep slopes during warm seasons and then fade in cooler seasons. They appear in several locations on Mars when temperatures are above -10 degrees Fahrenheit, -23 Celsius, and disappear at colder times. The hydrated minerals, which are most likely a mixture of magnesium perchlorate, magnesium chlorate, and sodium perchlorate, lower the freezing point of a liquid brine, allowing water to flow even in freezing temperatures. Scientists believe it's likely a shallow subsurface flow, with enough water wicking to the surface to explain the darkening. The detection of hydrated minerals on Mars is a significant development, as it confirms the presence of water on the planet's surface, which could have implications for the potential for life on Mars. The presence of liquid water is considered an essential requirement for life as we know it. The discovery of water on Mars raises new questions about the planet's geology and potential for past or present microbial life. Furthermore, the study adds to the ongoing debate about the history of water on Mars and how it transitioned from a water-rich environment to the cold desert it is today. Detecting hydrated minerals on the Martian surface is an exciting development. It will likely lead to further research and exploration to better understand the geology and potential habitability of the planet. A big question swirls around the origin of that water being discovered. Where is it coming from? One possibility is that the seeps are fueled by an aquifer or melting subsurface ice. These scenarios would have Mars sweating, with salt water seeping from its pores and trickling down slopes as the planet warms. The moisture might also be atmospheric in origin, which is the hypothesis the team favors. In this scenario, surface salts absorb water vapor in the Martian atmosphere. If the humidity in the Martian atmosphere gets high enough, perchlorate salts will absorb the atmospheric water until the salt dissolves and forms a liquid solution, says Mary Beth Wilhelm of NASA's Ames Research Center. Wherever its source, it's no surprise that there's water on Mars. Entire Martian landscapes have been sculpted by the stuff, including an ancient mile-deep sea, albeit billions of years ago when the planet was warmer and more watery. The fleet of spacecraft exploring the Martian surface continually returns data suggesting that water was once common. In conclusion, the new findings from NASA's MRO provide the most substantial evidence that liquid water flows intermittently on present-day Mars. Detecting hydrated minerals on the Martian surface is an exciting development. It will likely lead to further research and exploration to better understand the geology and potential habitability of the planet. The discovery of water on Mars raises new questions about the planet's geology and potential for past or present microbial life. However, the significance of this discovery is still unclear, as the amount of water is minimal, and it is unclear if this water is accessible for future missions and if it could support life. Does the planet Mars have a chance of restoring surface water? Do you believe the water can support life? Let us know in the comments section. Remember to like and share our video. Thank you for watching.